Hi, I'm Jan Ozer. I'm sitting here with Zoe Liu from Visionular, and we're here to talk about codecs. Hi, Zoe.
Hi, Jen. Thanks for having me down here. And it's always a great pleasure for us to discuss about Codec, especially with you.
It's always a lot of fun. So you at Visionular, you support 3 codecs. You support 264, 265, or HEVC, and AV1. What's new with AV1?
Well, AV1 actually has been here for 5 years, I would say, almost 6 years, because it was finalized in June 2018. Now it's the 6th year. I think the new things, I would say, the ecosystem is picking up. So everybody know that last year, Apple rolled out the iPhone 15, which is A17, that has AV1 hardware decoder available in that chipset. And then at the same time, we also see that, at least from our side, we see AV1 has been talked quite a bit. And first, of course, we got more use cases and leveraging our AV1 Ozer 1 encoder product to really deploy in different use cases. So we can see that AV1 is picking up and actually faster most recently that we have observed.
Is that live VOD?
Well, that's actually a good question. It's actually both. Because I would say first is the VOD is always the VOD case always benefit from the new generations of standards because standards has more new coding tools into that. Usually it's more complicated. So the VOD side is you can afford more CPU resources, more turnaround time, then you try to get higher quality and lower bit rate. So definitely on the VOD side, AV1 is also pick up. We actually received quite a bit more requests on that, and especially AV1 has the film grain synthesis for the very first time in the main profile. And then in the living room, we would say more and more TV set, they not only support AV1, but support AV1 synthesis. That actually adding another layer of support to AV1 VOD. At the same time, you mentioned you're asking about live. Especially, we have observed very opposite trending that for low latency, extremely low latency scenario for AV1, 2 things. One is AV1 for low latency live. The other one is AV1 for real-time communications, which is RTC. They all pick up. So, for example, right now we do live streaming, and then if someone needs, we recently have a use case, for example, it's actually drone and they need to capture video and really low delay to send the video back to the ground because they want to know in the ground what is going on in the air. So the delay has to be low. And on the other side, the bandwidth from the air down to the ground is very challenging. So originally, they installed the AVC 264 encoder, but the bandwidth is limited and the quality turns out not as ideal. When they switch from AVC to AV1, they observed dramatically with very limited bandwidth, I would say less than even 100 or 50 kilobits per second, they actually observe very good quality delivered by AV1. So this is one use case. On the other use case we just mentioned, for very low delay, there's an interaction. For example, we have meetings, and AV1 has a unique set of features, which is screen content coding, SCC features. This is the first time that as a standard, like AV1, including this set of features in its main profile. So every standard, every encoder using AV1 need to support, and the screen content is very unique from natural content. And we all know that, for example, even the background, for example, is orange, but because of lighting noise, the orange is not the same from this dot to that dot. If you have a screen, if you have a slide, and the background is orange, it will be orange everywhere, exactly the same pixel value. So definitely these two content different. If you have a dedicated screen content coding, you can save a lot of bits on such kind of content. So we recently have another use case. The use case is they actually for the security. So someone at the bank, they may add kiosk login from either a browser or from dedicated app, and then it could be hacked at that moment. So what our customer use is they actually put all this insensitive info to the backend, and all the backend generated the user side interface as a video and send this video back to the user side, so that when the user typing the password, what they see on the screen indeed is a decoded version that has been sent from the server side. So this side, you actually need a very low delay video that is being processed on the back end, and also very fast low delay decoding. This is all can leverage the AV1's ICC, the screen content coding tools. First, is high quality, because you want the user just feel everything just happen on local. Actually, there's a communication video transmission encoding happening. On the other side, you can have the low delay and just feel like everything but gain very high level of security. So those are use cases that you can leverage unique features. And of course, you need to get the encoder further optimized to fast enough but still maintains advantage by the AV1 standard.
What about AV1 in broadcast TV, including HDR, out to television sets and out to mobile?
Yes, I think for AV1, for the broadcasting, is because, as we mentioned, that it has more complicated tools, as long as you actually further optimize it, because in broadcasting live, usually you'll be able to tolerate into longer delay. So for example, even for sports live streaming, you usually can turn, for example, like up to 5-10 seconds, or sometimes even people talk about 30 seconds. So in that kind of low delay, in that kind of latency, not that low delay, but that kind of a latency level, you can average the encoding optimization to further leverage the AV1's new coding tools to further save the bitrate, get higher quality. And then, so in this kind of scenario, we also observe that AV1 is picking up because of the new set of coding tools. So boost up the quality, still save the setting cost, getting a little further layer bitrate.
So when AV1 first shipped, and it was, I guess it was launched 5 years ago or 6 years ago here.
Yes, that's right. It's June 2018 when it's finalized.
So
yes.
when I tested it for Streaming Media Magazine the first time,
yes.
I think it was 2,000 times real time. I mean, how did you get it down to not only real time, but also multiple outputs on a single computer real time? How did you get it so efficient on the encode side?
Well, that's actually every codec standard when they deploy kind of experience that. So when AV1 just rolled out, we still remember that it's MSU, Moscow State University, actually published actually on the early part of 2018, even before it was finalized. They mentioned that, wow, AV1 is about 2,000x slower. That first impression is I gave everybody's opinion that AV1 is good, but it's slow. Along the way, I think it's just like many other standards. So there's always a coding tools that can further optimize. There are also underlying assembly code that you can get it faster. So there's always a way that you can faster, and then you can leverage all kinds of different scenario, different use cases to optimize the tool set. So by today, not only us, we always mention that we are delivering commercial encoders, but we actually leverage a lot of open source and then the knowledge from the community. We always mention that we climb further down, further up, and by standing on top of the giant shoulders, which come from the open source community. Like there's mainly two open source AV1 encoder, LibAM, and SVT AV1. There's a great AV1 software decoder open source, David. And then all this actually contribute a lot the community to make AV1 getting faster and faster. So I just want to give one example, because this is not AV1. This is because we're doing MV HEVC for the demo. So MV HEVC is especially triggered by Vision Pro, because Vision Pro uses MVC to guide encoding those special videos. So when we actually got our own MVC encoder, we try to get a benchmark. So right now the benchmark is HTM. It is a reference software for the standard. It is really slow. actually, when we encode 1 minute Big Bad Bunny spatial videos, HTM needs 36 hours to encode 1 minute. So if I say, oh, this is so slow, then I'm HTVC slow. But I can tell everybody using our, not just our, I think others can potentially do that, but it's not available to us yet. So using our Aurora 5 HTVC encoder, we encode even smaller file size, better quality. We need only 42 seconds. So can you see MVHVC as a standard? It is slow. It's just that you have now optimized it. Same thing back to AV1. So 2018 is slow to nowadays. Everybody enjoy not only VOD live, but also low latency, just we mentioned. The latency there has to be lower than sometimes only tens of milliseconds, right? Even lower than 100 milliseconds. So with all this, maybe our encoder engineers dedicated together, and then we make the encoder better and better, really become more flexible and feasible.
Okay, what are you hearing about VVC at this point?
Yeah, I think VVC is also great standard because VVC was finalized in 2020, 2 years actually younger. And we already see that a lot of people are developing the VVC. And it's a little challenging right now. For example, when the browser start to support VVC, and then people ask about, we actually always think newer standard like VVC. Now there's an even newer standard on both sides. Like Unpack, they talk about ECM. On the AOM side, it's talk about AV2. There's a new tools that actually getting to the newer standards because you still want to get better quality, even lower bit rate. All these things are ongoing. And I have to say that AI also has been considered. There's actually new tools, but also very complicated. With this way, I think encoder also enjoy the whole set of technologies. Like if more faster hardware, like GPUs, not just on the server side, but on the mobile side. We all know that on Apple, there's NPU already really taking off on devices. And we can tell that potentially AI-based, even big model-based, that kind of coding tools will be included in the newer standard, new further optimization with the support of the newest generation of hardware, both CPUs, GPUs, and the dedicated chipset. I think we all can enjoy new technologies and even better quality, lower bit rate, even lower latency, and then everybody should be able to enjoy not only, I would say, higher quality, high resolution, but could be really enjoy the immersive video experiences.
So what about the AR, VR revolution that I guess a lot of people hope was going to drive the next generation of codec adoption? Apple came out with HEVC in their Vision Pro headset. What's the next big application that's going to drive demand for a new codec? What are you seeing?
Well, this is a little bit challenging question. So, for example, Vision Pro, we definitely hear from the market that ever since the launch of Vision Pro, even though it's challenging, people complaining maybe the battery seems like challenging. Also, the headset a little heavy to actually wear for more than 2 hours or sometimes even 1 hour. However, and then the immersive experiences that you get from Vision Pro is AR because you'll see the real world and also you see the virtual world, and also their technology detect the gesture of fingers and then the eyes, and that is very intriguing and innovative. So we would say that the immersive AR, it is one of the experiences. On the other side, everybody talk about now we have autonomous cars, right? So in that one, people are moving around, but you can see that a lot of video is being collected. And then those videos could be a large volume. So now we're talking about encoder, not just for getting the videos, serving the human eyes, because we experience, and then some of the videos are actually not serving human eyes, they're serving the machines to learn new things. And there's also, everybody know that there's OpenAI, they have the generative AI, they create so much very real and those kind of generative videos. And actually we analyzed the generative video. We found that it's very interesting because first we found that those videos still very different from the natural videos. They don't have that much noise. They have a lot higher contrasting. And the sharpening, actually the edges in those videos are usually much sharper actually the natural videos and closer to the computer generated videos. If you just from codec point of view, you can find, oh, these are not natural videos. It must be something that have been generated by machines. And also for the cameras, you can see that the camera motions little more regular. It's slightly different from the real world. So now you have a new generation of videos, and along the road we know that the generative video could create more and more natural video, but it's also create a lot more videos. Right now those videos are generated with a big model in the server side, and then you need a compression because you need to share them in the end and distribute it to the end devices. So with all of this, we have the generative videos, we have the videos served on different scenarios, and then we also know that Starlink, they actually serve the videos from the outer space back to. We actually have a team member here once joined the Artemis project back at WebEx. So WebEx at least got the first AV1 video call from the moon down to the Earth, but it's actually not video call, it's mainly 20-second delay down there. But with all of this, is actually technology driven, all these experiences with AIs, with our human beings exploring the world, not only on the Earth, but also on the outer space. And this is the second time that technology driven, the new use case in return gave the new challenge for these technologies. So we're all happy to be a part of this very innovative and fast-pacing world. And then I would say new things will come a lot faster than before.
Talk real briefly about the, I guess, H.267 and AV2.
Yeah. Okay, just on way to mention, H.267 is, just I mentioned, it's an ECM, something ongoing on the Unpack side. And on the other side, AV2, right now it's have a new name, AVM. That's actually ongoing on the AOM side. So right now, this is two organizations. They are the big driver behind the new Codec standards. And I would say they're still actually mainly for boosting photo quality and lower bit rate. But on the same time, we already mentioned they consider how do they leverage AI. So they do, for example, using the AI-based deblocking filter. It's amazing that sometimes they got even 7 to 10% bit rate savings by using that only coding tool. This is actually a lot. Usually standard from one generation to another generation, if you get 25 to 30%, and the standard condition is already the generation's difference. But now this one tool by AI, you actually obtain close to 10%. That's a lot. However, the complexity is huge. So as I mentioned, with the AI use, when you use hardware, when you get new hardware, not only on the server side, because the standard need to think about the standard mainly standardize the bitstream as well as the decoder behavior, right? You don't want to increase the decoder complexity that much. Then when the end devices has more and more computational power, not only for CPU, but for AIs, like we just mentioned, NPU, it is possible actually use more AI based to further down actually the file size at the same quality. So we believe both standards consider what they can do, because the standard is serving for future, next 5 years or even longer. So then they need to consider what's the new technologies. Everybody have to think about AI. So as we mentioned that they all think about AI, they all also look into what the hardware, what the chip side, what the other technologies that will drive those kind of tools deployment in the new standard. So it's everything together. When we talk about computational, talk about quantum computing, so when the computational power become exponentially developed, I would say new coding tools will be include this new standard beyond our imagination.
Okay, well, that's a great place to stop. Thanks for taking the time today.
Okay, thank you for having me. I hope that everybody can pay attention to video compression, and especially everybody deserves to enjoy the best video experiences.